0.5 centimeter in size is placed at 27 centimeter in front of concave mirror of radius of curvature 36 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Describe the nature and size of the image. And the third question is, if the candle is moved closer to the mirror, how would the screen have to be moved? So for this question, we have to form a ray diagram which shows all the given items. This is the principal axis. This is a concave mirror with pole P, and the back side I'll make this to show this is a cave-like figure of concave mirror. This is focus. This is center of curvature. The radius of curvature is given to be 36 centimeter. The focal length is given to be half of the radius of curvature, 18 centimeter. So this is 18 centimeter from the pole. So though the distance is given from mirror, the distance is measured always from pole and starting from pole only. And object suppose is AB. It is placed 27 centimeter from the pole. Now to form ray diagrams, we'll make a parallel ray falling on the mirror. It is reflected by back coming from focus. The other ray will fall on point P, will follow the rules or law of reflection, and angle of incidence will be equal to angle of reflection. This is I is equal to angle R. And this ray will touch the original first ray at this point, and there will form an image like this. So we need to find this distance, which is the distance of image from pole given by V. So according to Lenz's formula, 1 by F is equal to 1 by V plus 1 by U. So F is the focal length which is opposite to the direction of the incident ray. Like PF is opposite to, from P to F is opposite to the direction of ray which is coming from A to P, towards P. So F will be equal to minus 18. U will be equal to minus 27 because object is also placed against the direction of rays. So 1 by V is equal to 1 by F minus 1 by U, which is given by minus 1 by 18 plus 1 by 27, which is equal to, if I take LCM 54, this would be minus 3 plus 2 is equal to minus 1 by 54. So V is equal to minus 54 centimeter. Negative sign indicates that again it is placed, the image will be formed where the object is, or it is against the incident rays. The image will be formed in front of concave mirror only. To go for the next question, that so we need to keep our screen here at AB, which is 54 centimeter in front of concave mirror. So this is our first answer. And nature and size of the image. For nature and size, nature, as you can see, that real rays are coming and intersecting with each other. It's nothing virtual in this. Actual rays are coming and intersecting. So image will be real. And for size of the image, we need to go for the magnification formula M. M is equal to H2 by H1 is equal to minus V by U. H2 is the height of the image and H1 is the height of the object. So H2 will be equal to 2.5 into minus V. V was given as minus 54 and U was minus 27. So we can see that height of the image is coming out to be -5 centimeter. So negative sign indicates that the image will be formed below principal axis. So our image formed will be real, magnified, height of the image is more than that of object, and inverted. The sign is indicating us that it is below principal axis, it is inverted. So yes, and behind C. So this is answer for the second question. Now the third question is, if the candle is moved closer. Now candle right now is between C and F. So we'll make the cases where candle is moved closer to the mirror. So there can be two cases. Case 1, this is concave mirror. First case will be when the candle is at F. This is your candle A to B. Focal length is 18 centimeter. Now we'll again make ray diagrams. First ray parallel to principal axis. It will pass through F. Second ray at P. It will normally come like this, parallel to the other ray. So actually in this case the image will be formed at infinity, and we actually don't know the distance and the height of the image because it will be formed at infinity. Case 2 is when the object is placed between F and P, focus and pole. In this case, suppose object is here at AB. Now I'll make ray diagram by making a ray parallel. So this parallel ray will try to come back or converge like this, pass through F, but will not be able to pass through because the object itself will come in between. The other ray will fall like this at P, will follow the laws of reflection. I is equal to R, and we can extend both the rays virtually at the back of the mirror like this. And your image will be something like this. So in this case, in the second case, the image will be formed at the back of the mirror. It will be a bit magnified and it will be virtual. Virtual and erect, you have to write. And position will be the back of mirror and it will magnify. In this case, we cannot really tell about the magnification, but image will be formed at infinity. You have to write that.